The National Electrical Code, or NEC, defines the scope and responsibilities related to electrical service entrances. Article 230.2, titled Scope, addresses service entrance conductors and equipment intended for use as service entrances for buildings and other structures. This section broadly covers the components and requirements for establishing a safe and compliant service entrance. The NEC defines the service entrance as the point of connection between the facilities of the serving utility and the wiring system of the premises served. This definition is further clarified in Article 100, Definitions, which provides specific meanings for terms used throughout the code. Here, service entrance is defined as the point of connection between the service conductors and the interior wiring of the building or other structure. Therefore, the utility's responsibility ends at the service entrance, which is the point of connection between the service conductors and the interior wiring of the building. To elaborate, understanding the significance of the service entrance as the demarcation point is crucial for both utilities and consumers. It clearly establishes where the utility's responsibility for providing electrical power ends and where the building owner's responsibility for maintaining the internal wiring begins. This delineation is important for safety, maintenance, and troubleshooting purposes. When problems arise, knowing where the responsibility shifts can expedite the process of identifying and resolving issues. Consider a scenario where a fault occurs in the electrical system. If the fault is located on the utility side of the service entrance, the utility is responsible for addressing it. However, if the fault is within the building's wiring system, the building owner is responsible for repairs. This distinction prevents confusion and ensures that the appropriate party takes action. The service entrance typically includes several key components such as the service drop or service lateral, the service head or weatherhead, the service entrance conductors, and the service disconnect. The service drop refers to the overhead conductors that run from the utility pole to the building. The service lateral, on the other hand, refers to the underground conductors that serve the same purpose. The service head or weatherhead is a protective fitting that prevents water from entering the service entrance conductors. The service entrance conductors carry the electrical power from the service drop or lateral to the service disconnect, which is the main switch that allows the building owner to shut off all power to the building. The location of the service entrance can vary depending on the specific installation and the local requirements. In some cases, the service entrance may be located on the exterior of the building, while in other cases, it may be located inside the building, typically in a meter room or electrical room. Regardless of its location, the service entrance must comply with all applicable requirements of the NEC and local codes. The NEC provides detailed requirements for the installation and maintenance of service entrances. These requirements cover various aspects such as the size and type of conductors, the overcurrent protection, the grounding, and the clearances. The purpose of these requirements is to ensure that the service entrance is safe, reliable, and capable of handling the electrical load of the building. For example, the NEC specifies the minimum size of the service entrance conductors based on the calculated load of the building. The calculated load takes into account the various electrical appliances and equipment that are likely to be used in a building, as well as any anticipated future loads. The NEC also requires that the service entrance conductors be protected by overcurrent devices, such as circuit breakers or fuses. These devices are designed to interrupt the flow of electricity in the event of a short circuit or overload, thereby preventing damage to the conductors and equipment and reducing the risk of fire. Grounding is another critical aspect of service entrance installations. The NEC requires that the service entrance be properly grounded to provide a low impedance path for fault currents to return to the source. This grounding system helps to protect people from electric shock and to minimize the risk of damage to equipment. The NEC also specifies minimum clearances for service entrance conductors from buildings, ground, and other objects. These clearances are intended to prevent accidental contact with energized conductors and to ensure that the conductors are not damaged by physical contact. In addition to the NEC requirements, local codes and regulations may also apply to service entrance installations. These local requirements may vary depending on the jurisdiction and may address specific concerns or conditions in the area. It is important to consult with local authorities and qualified electrical professionals to ensure that all applicable requirements are met. When designing and installing a service entrance, it is essential to consider the existing and future electrical needs of the building. The service entrance should be sized to accommodate the current load, as well as any anticipated future loads. It is also important to choose the appropriate type of service entrance conductors and equipment to ensure compatibility with the building's electrical system and to meet the specific requirements of the application. Regular maintenance and inspection of the service entrance are also important to ensure its continued safe and reliable operation. Over time, service entrance conductors and equipment can deteriorate due to exposure to the elements, corrosion, and other factors. Regular inspections can help to identify potential problems before they become serious and to ensure that the service entrance is operating within its design parameters. Any necessary repairs or replacements should be performed by qualified electrical professionals. In summary, the NEC defines the service entrance as the point of connection between the utilities facilities and the building's wiring system. This demarcation point establishes the boundaries of responsibility between the utility and the building owner. Understanding the requirements for service entrance installations is essential for ensuring the safety, reliability, and compliance of electrical systems. By adhering to the NEC and local codes, and by performing regular maintenance and inspections, building owners and electrical professionals can help to prevent electrical hazards and to ensure the safe and efficient delivery of electrical power. The point of connection is a critical concept. It isn't just about wires meeting, it's about where accountability shifts. The utility is responsible for maintaining the power supply up to that point, ensuring the correct voltage and current are delivered safely. Beyond that connection, the building owner takes over, responsible for the integrity and safety of their internal wiring. This includes everything from the main panel to the outlets and appliances within the building. The NEC provides specific guidelines for the types of equipment that can be used at the service entrance. These guidelines are in place to ensure that the equipment is rated for the voltage and current levels that will be present and that it is suitable for the environmental conditions in which it will be installed. For example, service entrance equipment that is installed outdoors must be rated for wet locations. The NEC also provides specific requirements for the grounding of service entrance equipment. Grounding is essential for safety because it provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC requires that the service entrance be grounded to a grounding electrode system, which typically consists of a ground rod or a metal water pipe that is buried in the ground. The NEC also specifies the size of the grounding conductors that must be used. The size of the grounding conductors is based on the size of the service entrance conductors. The NEC also addresses the issue of overcurrent protection for service entrance conductors. Overcurrent protection is essential for safety because it helps to prevent the conductors from overheating and causing a fire. The NEC requires that service entrance conductors be protected by circuit breakers or fuses. The size of the circuit breakers or fuses is based on the size of the service entrance conductors. The NEC also provides specific requirements for the location of the service disconnect. The service disconnect is the main switch that allows the building owner to shut off all power to the building. The NEC requires that the service disconnect be located in a readily accessible location so that it can be easily reached in an emergency. The NEC also requires that the service disconnect be clearly labeled so that it can be easily identified. In addition to the NEC requirements, local codes and regulations may also apply to service entrance installations. These local requirements may vary depending on the jurisdiction and may address specific concerns or conditions in the area. It is important to consult with local authorities and qualified electrical professionals to ensure that all applicable requirements are met. Therefore, it is essential to consult the latest edition of the NEC and any applicable local codes before designing or installing a service entrance. Working with a qualified electrical contractor is highly recommended to ensure that the installation is safe, compliant, and meets the building's electrical needs. The NEC isn't just a set of rules, it's a living document that is constantly updated to reflect the latest technologies and best practices in the electrical industry. Understanding the NEC requirements for service entrances is crucial for anyone involved in the design, installation, or maintenance of electrical systems. By following the NEC guidelines, you can help to ensure the safety and reliability of electrical systems and protect people from electric shock and fire hazards. Remember, electricity is a powerful force and it must be handled with care. Always consult with a qualified electrical professional before working on any electrical system. The NEC provides detailed tables and examples to assist in calculating the appropriate size of conductors and overcurrent protection devices. These calculations take into account factors such as the type of load, the voltage, the ambient temperature, and the type of insulation used in the conductors. The NEC also provides guidance on the selection of appropriate wiring methods for service entrance conductors. Wiring methods refer to the way in which conductors are installed and protected. Common wiring methods for service entrance conductors include conduit cable and direct burial. The NEC specifies the types of wiring methods that are permitted for different applications and provides requirements for the installation of each wiring method. Furthermore, the NEC addresses the issue of surge protection for service entrance equipment. Surge protection is important because it helps to protect sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other events. The NEC recommends the use of surge protective devices, or SPDs, at the service entrance to protect against voltage surges. The NEC also provides guidance on the selection and installation of SPD. Another important aspect of service entrance installations is the coordination of overcurrent protection devices. Coordination refers to the selection and arrangement of overcurrent protection devices in such a way that the device closest to the fault will trip first, minimizing the impact of the fault on the rest of the electrical system. The NEC provides guidance on the coordination of overcurrent protection devices to ensure that the electrical system is properly protected. Also, the NEC emphasizes the importance of proper labeling of service entrance equipment. Labeling helps to identify the different components of the service entrance and to provide information about their function and ratings. The NEC requires that service entrance equipment be labeled with the voltage, current, and interrupting rating. The NEC also requires that the service disconnect be labeled to indicate its purpose. In addition, the NEC addresses the issue of accessibility for service entrance equipment. Accessibility refers to the ability to reach and work on the equipment safely and easily. The NEC requires that service entrance equipment be accessible for inspection, maintenance, and repair. The NEC also specifies minimum clearances around service entrance equipment to ensure that workers have enough space to perform their tasks safely. It is important to note that the NEC is not a design manual. It provides minimum requirements for the safe installation of electrical systems, but it does not provide detailed design guidance. The design of an electrical system should be performed by a qualified electrical engineer or designer who is familiar with the NEC and other applicable codes and standards. The NEC is a complex and comprehensive document, and it is essential to have a thorough understanding of its requirements before working on any electrical system. The NEC is updated every 3 years, and it is important to use the latest edition of the code. The NEC is available for purchase from the National Fire Protection Association, or NFPA. The NFPA also offers training and certification programs for electrical professionals. By staying up to date with the NEC and participating in training programs, electrical professionals can ensure that they have the knowledge and skills necessary to design, install, and maintain safe and reliable electrical systems. In conclusion, understanding the NEC definition of the service entrance and the associated responsibilities is paramount for ensuring electrical safety and compliance. The service entrance serves as the crucial point of demarcation between the utilities and the building owner's electrical systems. Adhering to the NEC guidelines and engaging qualified professionals are essential for safe and efficient electrical installations.